Today's lesson is from section 9.6 in the textbook, and it is called Translating Hyperbolas. During this lesson, I want you to have this document at hand because it has information about hyperbolas, and also we're going to do a little bit with parabolas later on. You've got them right here. So without further ado, let's take a look at the first example. What I want you to do is graph the conic section y minus 2, the quantity squared, over 9, minus, and it's that minus right there that's going to tell us we're looking at a hyperbola, x plus 1, the quantity squared, over 1 is equal to 1. So the first step in graphing is to identify which axis is going to have the hyperbola. Is it going to be an up-down hyperbola, or is it going to be a left-right hyperbola? And what we do is we look at the first term. So this first term here is a y term, and that tells us that it will be in the direction of the y-axis. The y-axis is vertical, up, down, so this is going to be an up and down hyperbola. The next thing we want to do is identify where the center of the hyperbola will be, and the center is going to be identified by the hk values that we have right here. So the x is with plus 1, which tells us that the x value will be negative 1. And the y is with negative 2, which tells us that the y value of the center will be a 2. So we've now got our up, down, and our center. Let's draw an axis. And I'm going to plot that center at negative 1, 1, 2. And then we're going to build the hyperbola box. This number in the denominator tells us that the distance squared is 9. So in the y direction, we're going to go from the center up 3, 1, 2, 3. Down 3, 1, 2, 3. In the x direction, the distance squared is 1. So if we take the square root of that, we get 1. We're going to move 1 to the right and 1 to the left. And those 4 points are going to guide our hyperbola. So let's build the box. Now notice that I'm dashing. And the reason that I am dashing is because this box is not actually part of the set of solutions. Now that we've got the box, we can build our asymptotes. They just run right through the diagonals of the box. And now we can draw the hyperbola. Now we did some important legwork early because we identified that this is going to be an up-down. And that tells us that our vertices are going to be here, so that we get this part of the hyperbola. So what I'm drawing now is actually part of the solution set. And then our other vertex is going to be here, so that this is also part of our solution set. Just hugs those asymptotes. We need to identify where the focus points are going to be for this hyperbola. And recall that our equation for the foci is c squared equals a squared plus sine is always opposite of what we have in the function, b squared. So in this case, c squared will be equal to 9 plus 1. So c squared is equal to 10. Take the square root of both sides, and we get that C will be approximately plus or minus 3.2. Now that 3.2 tells us where our foci are going to be. We come back to the center, just like we did to get the vertices. The foci are always going to be on the same axis as the vertices, so I'm going to go up 1, 2, 3, and a little bit more. There's a focus. Notice that the hyperbola eats the focus. I'm going to come back to the center, down 1, 2, 3, and a little bit more. There's our focus. Notice that the hyperbola eats the focus. Okay. So there's our hyperbola. Now, put down your pencil and just watch for a minute. And I want to show you what happens if we change the two terms. So let's suppose we took these two terms and we switched them. That would look something like this. Now what I want you to notice is that now that we've got x in the first term, that tells us that our hyperbola is going to be on the x or horizontal axis. So this one's going to go left, right, and we get a very different shape because now we've got a vertex here and a vertex here. So there's our hyperbola. There's our hyperbola. And our foci would be at 1, 2, 3, and a little bit more. 1, 2, 3, and a little bit more. Okay, so that's one thing we could do to change things up. Let's look at a different situation. Suppose instead of switching the two terms, we turn this into a positive sign. Okay, so something that looks like this. That positive now tells us that instead of having a hyperbola, we're going to have a completely different shape. We're going to have an ellipse. Okay, and so if we have an ellipse, we don't have to draw the box. Instead, we can take those points and we can use it to draw this figure right here. Okay. Vertices, co-vertices. All right, so that's it for graphing. Let's look at a little bit of equation writing. Pick up your pencil again. We're going to do two more examples. Let's call this one number 2. Write with me now. I want you to write the equation of the hyperbola. That has this information. The vertices are at -1, 3, and at 5, 3. The foci are at -3, 3, and at 7, 3. And like a lot of the problems that we've been looking at lately, there's really no solid way to figure out what the equation is without first drawing a picture. So I'm going to draw a little sketch here. And keep in mind that this can be a rough sketch because our goal in this case is not to draw the picture, but just to use the picture in order to help us come up with the equation. Well, for starters, we got our vertices. One of them right here is at -1, 1, 2, 3. And the second one is here at 1, 2, 3, 4, 5, 1, 2, 3. And then our foci are at -3, 1, 2, 3. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay, so this has done a couple of things for us. First, it tells us that this horizontal axis is going to be the axis on which our hyperbola is centered. So it's going to look something like this and that. And it also tells us where our center is going to be, and we need that center. See those two vertices? We know that the center has to be halfway in between them. So I'm going to count 1, 2, 3, 4, 5, 6 units between them. I'm going to cut 6 in half, so that gives us 3. There's our center. So that center is at the point 2, 3. And now we're ready to start writing our equation. Here we go. So first thing, the central axis here is the horizontal or x-axis. So our first term is going to be an x term. I'm going to say x minus 2, because the center has a 2, squared over that distance from the center to the vertex is what tells us the number that's going to go here. So in this case it's 3, which tells us that this is going to be 3 squared. Minus y. The center has a value of 3 for y, so y minus 3 squared over, and now we're in just a little bit of trouble because we don't know the number that's going to go right here. Now, there's one part of the picture that I didn't draw, and that's the box. And I don't know exactly how wide it should be, but I know that this distance right here is what we're looking for to put in this position. So let's use the focus equation to help us. The focus equation goes like this. C squared is equal to a squared plus b squared. And we know C is this distance from the center to the focus. Count it up. 1, 2, 3, 4, 5. So our focus equation is going to go 5 squared is equal to 3 squared. I'm getting that 3 from the distance from the center to the vertex, plus b squared. And b squared is what we're looking at to put in here. So 25 is equal to 9 plus b squared. If we subtract 9 from both sides, we're going to get that 16 is equal to b squared. And therefore, when we root and we root, b is going to be equal to plus or minus 4. So let's bring that up here. That means a 4 squared goes in that position. It's all equal to 1. Let's rewrite it. Our final answer is that the hyperbola equation is x minus 2 squared over 9 minus y minus 3 squared over 16 equals 1. Okay. Last example for today. Let's call this number 3. I want you to write the equation of a parabola with the following information. The vertex is at 2, 3, and the focus is at 7, 3. And again, the best way to get a handle on something like this is to draw a little sketch. So we've got a vertex at 2, 3. I picked that point because it's the same vertex that we had for the hyperbola. And then the focus is at 7. So 1, 2, 3, 4, 5, 6, 7, 3. Okay, and this is helpful to us because we can now tell what direction our parabola is going to go in. We know that the parabola goes through the vertex, and it eats the focus. So it's going to look something like that. Ooh, so it opens right. Now if you look at your little formula sheet here, if it's right, that means we're going to have one of the parabolas that starts with a y. So let's write our equation. Y. Our vertex is at 2, 3. So 3 is the y value of the vertex, minus 3. The quantity squared is equal to 4 times our p-value, which we have not determined yet, times the x component of the equation. Notice that the x component for parabolas is not squared. X in the vertex, 2 is the x value, so we put minus 2. And then the last piece is to determine what p-value goes here. Well, that p-value is the distance from the vertex to the focus. And that distance is 1, 2, 3, 4, 5. So p is equal to 5. Let's bring that over, plug that in, so that our final equation looks like so. Y minus 3, the quantity squared, is equal to 4 times 5 gives us 20, x minus 2. That concludes today's notes. For the assignment that you're going to complete in class today, there are going to be some hyperbolas, which was the main focus of today's lesson, but there are also going to be some parabolas and some circles and some ellipses. So the challenge is going to be figuring out which is which, and to help yourself, use this sheet throughout.